With great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. Trino Community Broadcast is a show where we cover events and happenings within the open source Trino community and show off some cool stuff that people like Corey Darby are doing in the Trino community. So welcome back, Corey. You're a long awaited member that we had, I think, on the second episode, if I'm not mistaken, right?
It was pretty early.
So. Yeah. Early days. So Corey, just for folks that did not catch that second episode, could you introduce yourself and talk a little bit about what you do?
Sure. So I'm a principal software developer at a company called BlueCat, which is in the DNS space. And I've been there for about 2 years, and I'm really just running the big data platform there, building it from nothing to what it is today.
Awesome. And as usual, our typical co-host and my partner in crime, Manfred Moser.
Hey everyone, can you believe it? It's episode 19.
Yeah, I know. Bad. We're getting up in the numbers. I mean, like I remember double digits was a big deal, and now we're 10 past that. So or getting close to 10 past that.
We'll work our way to triple digits, right?
Yep.
Although we'll never keep up with some podcasts that are like episodes so many hundred something.
Yeah, we need to move to daily podcasts. That's, I think, what you're telling me.
Yeah, I'm not sure about that. We'd have to have more Trino developers and contributors. So bring it, people.
For sure. And at least more, like one more developer advocate, so I could, get a little break here and there. But
who needs that?
Yeah, that's right. Nobody needs a break. So real quick, before we jump right into the releases and some of the cool news that we have coming up, let's do a quick word from our sponsors, Starburst.
I'm Colleen Tarto. I am the Director of Engineering on Starburst Galaxy.
What is it actually offering? So, I mean, I think this kind of like builds on some of the open source Trino stuff, but is it doing a lot more? What kind of pains is it solving? Could you kind of give us a little bit of insight on what actual pain this is going to be alleviating?
Yeah, absolutely. And so to think about that, I always like to go back and think about what's the difference between Starburst Enterprise and Trino, right? And so I always like to think of Starburst Enterprise as the cool older sibling to Trino. It's a little bit more mature, a little cooler. It's got a car. It's got some cool stuff going on, leather jacket, And Trino is awesome in its own right. Don't get me wrong, but Starburst Enterprise is just better and a bit more grown up. And specifically what that means to me is that with Enterprise, you get more functionality, faster performance, more connectors, more security, better management, better integration into the ecosystem of tools that you already use today, data governance, integration, et cetera. But what really speaks volumes to me is that when you use Starburst Enterprise, you get Starburst, right? You get best-in-class support from the folks who work for us, and they know Trino best because they created Trino, and they're continuing to contribute to Trino. But Starburst Galaxy takes that to a whole nother level, right? So one of the pain points is installing, managing, maintaining, monitoring Starburst Enterprise. And so Starburst Galaxy alleviates all of that, right? So it's a fully managed service. It's Starburst Enterprise as a managed service and more.
What's the experience there for developers on Kubernetes first? And then on contrast, what would Galaxy look like?
Yeah, and I mean, I think Kubernetes, like you get all the benefits of Kubernetes, like it's self-healing and, it's sort of like a modern way to manage it, but you're still managing it yourself, right? And so you still have to monitor it. If it goes down, it's still your responsibility, that sort of thing. Whereas Starburst Galaxy is a software as a service offering, right? So like we are taking in that responsibility of installing, managing, maintaining, monitoring the service, right? And so it's a huge win, like who wants the pain of that? And so, it's kind of like, there are other products out there. This is really just, it's 2021. This is the way the world's working now, is that things are available as a service, which is great because now Starburst is playing that game as well. I think there are a lot of exciting roadmap ideas of what we can build into Galaxy. And because it's a hosted platform, the sky's the limit, right? First and foremost, we're focusing on performance and flexibility. And then beyond that, there are exciting features that are either already available now or they're en route. Like in the immediate future, we're like updating our query editor and our notebook environment. We're thinking about usage and query optimization metrics built into the environment, so you can easily see, what are your users doing, what queries are being run, what's taking the most time, how can you like tune billing and things like that. Obviously, we've got our BI and data science tool integrations and more. I'm also excited about more advanced things like the ability to do cross-cluster analyses within the environment of Galaxy, but also hybrid analytics. So the idea of like going across cloud environments. So right now we're just in AWS. We're quickly going to be adding GCP and Azure and potentially other clouds. But the idea is like, what if you have data in multiple clouds? Like just being able to like, click a few clicks and then you're automatically analyzing data across clouds. That's really exciting to me.
Do we have any plans for like data governance in terms of like, you have now all of this, these catalogs, this, and it's kind of hard to manage a lot of that and understand where to find it all once you're able to get there, but like, where's the map? And so do we have anything that we've been working on with any partner companies or anybody that could help us in that direction? I know there's like open source projects like a Munson that people can use, but like there's
I think there's a lot of really cool projects out there involving data governance. There's a lot of really cool products in cataloging worlds. And we are, excited to bring that all into Galaxy. So that is absolutely on the roadmap.
And one last question, is there going to be any free offerings coming up anytime soon? Is that on the roadmap?
Absolutely. We've got a free trial. So if you're interested, absolutely reach out to us. We are very excited about it. And then we're talking about sort of a free tier. So like being able to just play around with it in your own environment and see what's what.
We'll keep you all up to date on when you can start to play around with Galaxy and Trino for free for just a little bit and get to know this incredible service called Starburst Galaxy. Thank you so much, Colleen.
Thank you.
All right. So Manfred, we skipped around like the last 2 episodes. We have been like starving everyone of release notes because I think we preemptively did the release 356 on like episode 16, and then like there was a bit of a delay, I think a release on 357 or something, and then we had like this 3-week shift of when we actually did the last episode with Angeli. So I'm like, we need to catch up now. So I think we have 2 releases,
the train
right?
doesn't stop, man. We fell off. Let's better hop back on. 2 releases went out. We have 357 and 358 went out the door. And I hear that 359 already has a whole bunch of cool changes in it as well. So might want to check out what's going on. So 357 came out on the 21st of May, and then 358 on the 1st of June. So, well, it's already the 10th,
Yep.
Time is ticking. I think by next time we'll have 359. So let's see what happened. So 357, here the suggestions that Martin had. Obviously, the release notes, as you can see, they're always long and technical. So sometimes it gets a bit hard to digest what's happening. But you can check out on your specific connector what happened. Like I know Brian loves his Elasticsearch connector, for example. So you can see something is happening. But let's see what Martin said. So the highlights Martin said are support for subquery expressions that produce multiple columns. And then support for current catalog, which is kind of cool because, you can use the use command, like use this and this catalog and schema. And then you can also pass that in via the JDBC string or in the CLI as command. And then that is now a variable that's available. So you can go and do some analytics based on whatever the current catalog and schema is, right? So that can be kind of handy. Aggregation pushdown made it into the ClickHouse connector. So that's a pretty new connector. It's definitely active, being developed, which is pretty good news, I think.
That's pretty cool. Quick turnaround too.
Yeah, aggregation pushdown is not that new, but of course it is implemented in the SPI. So people can see how to hook into it. And there's example implementation in the Hive connector, and I think one of the others as well. But basically, you can look for how it's done and then figure out how that would work with your connector. And the ClickHouse contributor stepped up and did that. So that's pretty awesome, I think. We had support for identifier mapping in various connectors with rules. And then one thing that I think is pretty cool is the new format number function. We'll talk about that later, I hear. So I'm not going to spoil that. And then we can cast row types as JSON objects now, which is pretty cool because sometimes, the downstream processing ends up being JSON objects. So that's what Martin thought is really cool. Of course, I always find other things that I think are cool because obviously other people have other perspectives. So, we get people that talk about dynamic filtering all the time, and then they're like, well, is it working or is it not? Well, now you can, that's printed in the summary in the explain plan. So if you go explain, analyze, you can clearly see it now if dynamic filtering is going on or not. So that helps a lot for troubleshooting performance.
Yeah, you remember that hack that we had to do on the episode 11? It was like
it was just
we had to pull out the JSON and actually check into all the different I can't remember. You had to know a couple of the fields to search.
You had to know what you're looking for. I mean, don't get me wrong. Explain plan reading is not simple. There's a lot of things going on, but it is a bit cleaner now and easier to at least find the dynamic filters. And we're also working on clarifying this more with like push downs and stuff like that. Hopefully we'll get some of that stuff implemented as well.
Awesome.
Now a cool thing that happened is the certificate usage for globally trusted certificates for OAuth is now fixed because it now hooks into the system trust store rather than the one that's used for internal communication. So that makes OAuth a bit more functional. Obviously, when you're securing, like when you're using any authentication, you should be securing Trino. And when you do that, please use a globally trusted certificate to do yourself a favor and do all your customers/users with your client tools a favor, because the last thing you want to do is muck around with certificate files and Java key stores and all that kind of jazz. So now that problem is also gone for OAuth 2. So very nice. Another little thing, if you're using the CLI, the Trino CLI, which is really powerful actually to write queries and stuff, there's now a little clear command. So if you're using in interactive mode and you have results going past and whatever, you can now run clear, clears the screen, and you can sort of clean up again and see what's going on. And then, as always, as you can also see here, there's numerous connector changes, right? Like a whole bunch of them, and so it's active and always going on. The people from Google helped with BigQuery, ClickHouse got some stuff, and all the others got some little changes as well. So check your favorite connector and see what happened there if you are so inclined. But then we have another release to talk about. So let's talk about 358. 358 was followed pretty quickly, and it has still some cool features in it. Show stats is now supported for arbitrary queries. So that can be useful again for figuring out performance things when you have bottlenecks or whatever, what's going on, reformatting your query, figuring out how you do the join ordering and stuff like that if necessary. Then there's some performance improvements on order by limit queries. Remember how that works is when there's a limit query, it's sort of like on the fly, doesn't even look at things that are too small, and that can make huge performance improvement in general. And now the developers gone in and made that even more supported. Another thing that's happening, it's the Coral library that we have for supporting high views keeps getting improved. Now we have support for lateral views in it. So that library is basically constantly being worked in, and people that are stuck with having to also work with old legacy high views will love that feature because lateral views are used quite a bit.
And if you want to know more about that too, check out our last episode on episode 18.
Yeah, if you're confused about views, and who isn't, check out that episode. And yeah, we will also clarify a few of those things in the connector documentation, by the way. We started to do the connector documentation to have every connector having requirements. So one of the things we want to do next, by the way, is we want to have SQL support, like really detailing which connector supports what specific things. And that includes views. So
views can be pretty confusing depending on your point of view.
Yeah, exactly. All right. And then another thing that happened is graceful shutdown was changed in terms of time. Graceful shutdown is, as you know, there's an API that you can sort of like ping onto a worker, and then it's gracefully sort of waits until all the load is drained off it, doesn't take anymore, and then it shuts down. That timing was reduced. Shouldn't affect really anyone because it was really big. But if you are using graceful shutdown in your process, just check out how it was reduced and make sure it doesn't impact your processes negatively. Most likely not going to happen, but if you are so inclined. There were a bunch of smaller changes on performance and correctness fixes. You can check them out in the release notes, just like little things for predicate usage with in statements and stuff like that. It really depends on the query, but generally just the quality of Trino is just like going up in levels really well again. And then the last one that's a sort of semi-breaking changes, the JDBC Presto string is no longer JDBC : Presto. Is no longer supported by the JDBC driver. We cleaned out that old mess and we are all Trino now. So Commander Bun all the way.
Yes, get rid of that Presto mess.
Yeah, exactly.
All right.
So those are the releases, and more is already in the pipe for 359, but we'll talk about that next time. There's some exciting things, and we might even have a spoiler later when we talk about some software that Corey is using. But
it's great. It's like every 2 weeks, it's like Christmas with Trino. So it's like every 2 weeks I check the release notes, like, ooh, what new features can I use?
Exactly.
So got a comment here from Nick, or sorry, from Jan, I think actually is saying a lot of Commander Bun buns. Yeah, I figured today, I actually had a question, like, is there enough Commander Bun buns here?
I mean, they have to dress up differently, I guess.
Yeah. So anyways, definitely let me know if you think we need more Commander Bun buns in everybody's background, and we'll work on getting you more of those. So all right, anything else we needed to touch on with releases before we move on?
No, let's move on. There's so much cool stuff to talk about. Let's go
to the concept of the week. All right, Corey. So tell us a little bit about if it will show. Let's see. Let me try to remove it and then add it one more time. You mind? How about this, Corey? Can you mind stop sharing and then share one more time?
Yep.
Yeah. There we go.
By the way, everyone, everything looks different and brand new because we changed to a different provider that sorts out all the streaming woes. Brian doesn't have to figure out hardware buttons on his sound mixer board and play around with OBS anymore. But new tools also bring new problems, as you all know.
That's right.
Yeah, I just actually, when I switch to share, if I have it on another workspace, it won't do it. So that's why when you were trying to switch, it was nothing. But anyways, we sorted it out.
We got it.
But just in general, I think it looks pretty damn good. So thanks, Brian, for kicking this in and doing the little branding and stuff. Looking good. Yeah,
great. So Corey, tell us about. Okay, so I mean, today I'm wanting to know about you all are super early adopters. I mean, Iceberg is this kind of, I mean, newish, and like for some people it might be newish. For others, this may be the first time you're hearing about it. We have a couple previous episodes where we go kind of deep into Iceberg. One with the creator of Iceberg, Ryan Blue. But then like now I'm wanting to kind of understand more like how other companies other than Netflix are using this. So that's going to be a real big treat for us today. But then you all use kind of tools that like Flink, and you're using Pulsar and all this really kind of up level stuff. Like we're in the Trino community broadcast, we're usually talking about Trino, right? And that's usually hitting on like we're talking about pulling the data out and trying to serve the data to our customers or internally for a different process. And so now we're kind of more interested on like ingestion, right? And trying to think like, how does that data get there in the first place? And, a lot of times, engineers are in our own space, like, we like to think, oh, well, no, we don't touch that in Trino. But now that we're kind of trying to work on the same table formats, like there has to be a level of collaboration. And Iceberg has made that incredibly simple. Providing
no spoilers.
Okay, but anyways, but it still requires like us to think about the upstream process, right? And so that's what we want to kind of talk about today, and you're going to kind of detail that and how you all have done that in BlueCat. So tell us about your journey at for ingestion at BlueCat.
Yeah. So just a little context. We had been looking at Iceberg before we jumped in the slides. Honestly, almost a year ago. And it just wasn't at the spot of Flink support and the required features that we were needing. So we basically passed on it and are a pretty typical, I think, Trino story, which is we're using the Hive connector. And we'll see, but there was a lot of issues with this. And it kind of led to this journey of, okay, we need to move off of that or start looking at other things. So let's just jump into it. Oh, I guess the next key didn't work. So context, BlueCat is where I work. Essentially, we're in what's called the DDI space, which is DNS, DHCP, and IPAM. So we power all your typically internal private DNS. And then where I work, there's two different teams that are mainly behind this. And it's mostly one on the research side and one more on the data platform building and infrastructure side. So let's talk about how this all came about. So at BlueCat, our current or prior system, like we're in this middle of migration. So when I first joined, it was all single tenant. So each customer gets their own block of everything. They live in their own space. The pipeline kind of looked like this. Customer sends in data. We use Amazon, so it goes through Firehose. We push into something like S3. And then eventually we have a Lambda that picks this up and puts it into Elasticsearch. So internally, there's just challenges with this, like how do we roll out all the changes to the customer? Your cost of goods sold is quite high because, our smallest customer would show up, and just to get them started, I have to spin up like 5-node cluster for Elasticsearch just to start, even if they're not sending us data. So we basically sat down and said, we need to move to multi-tenant, and let's start migrating off of this. And how do we do this? Right now, because we have existing kind of legacy ingestion, we're piggybacking off of that. So we're letting everything go through the old pipeline of ingestion, and then we're just pulling from the S3 buckets into Pulsar. Now, Pulsar is very similar to Kafka if you're from that world. Just place to store your events, your messages, whatever it may be. We're storing it in this case, protobuf into Pulsar. And then we have something like Flink, which is similar to like Spark or SAMS if you're from that world. And that's just providing us a framework in Java to interface with something like Pulsar or Kafka or a bunch of inputs, and then provides us a bunch of outputs. And it just...
silly question, just to jump in. Apache Pulsar and Apache Flink, both of them are top-level Apache projects that have been around for a while, or are they pretty new? Or?
Yeah, they're both out of incubator stage. I know Pulsar, I think a year and a half ago, was in incubator, but they've graduated out of that. So they should, yeah.
So pretty modern, but with the Apache Software Foundation.
Yeah. So still new relatively to other things in there, right? But definitely fully supported, full communities, and really like full steam ahead kind of scenarios. Awesome. So. Yeah, so similar tools, just different kind of tools.
I know this is a little divisive, answer at your own, but is there a particular reason why you chose Pulsar over Kafka? Because I know a lot of people I think the majority right now are Kafka, but nobody attacked, but it's like what's your claim for kind of like moving for Pulsar?
Yeah, so I used to work at a prior company that ran quite large Kafka cluster, plus 100 terabyte kind of Kafka clusters. And we just had a lot of operation burdens around that. Now, the Kafka KIPs have greatly improved since that time as well. But the big selling point for us with Pulsar is you get a pub sub model that you can opt into. So basically, you have a consumer, and it's a subscription, and you say every message in here, if all my consumers say they've seen the message, you can delete the message. In Kafka, you just have retention typically. So you set I want to keep everything for 1 day or 4 days. And this creates a really large pipeline. For us, it's once the consumers have all acknowledged they've got the message, we're free to delete it. We've already synced that data in S3. It's very expensive for us to keep everything in Pulsar, or in this case, even Kafka. If you kept 4 days of all our data, we're talking, I don't know, maybe $500 not 500, like 50 TB or something like that, maybe. Versus this way, we keep it as minimal. Like if everything is up to date, we keep basically nothing in there, a couple of gigs. And that's just for the consumers to say, yep, I got the message. And once they've got it, we delete from Pulsar. So yeah, that's the main thing. It was just a cost thing and the operations. But we're a new tool block. So like brand new system, you got to revisit everything and look around and go, okay, where's everyone going? What are we looking for? Okay, we can do that. So
good. Oh, good to know.
Yeah, so this was the first kind of stage. Moved back like a year ago. We were kind of in this spot, like, hey, we need to start syncing things over, and what's that look like? So once we had everything moving into Pulsar and Flink pulling it off of that, we basically now had this multi-tenant S3 bucket, right? Everything is going from single tenant in different accounts into one kind of global account or centralized account. And great, we have all the data. And this is where we start interfacing with Trino. So we started having Trino use the Hive connector with Glue Crawler, and we were able to actually generate reports off of our data. So this was like the first kind of iteration of, hey, look, we don't necessarily need Elasticsearch for some of the stuff, and we can start building new features. So, I mean, I can jump into why we picked Trino, but if you're here at the Trino live broadcast, you probably have a good idea of why we're using Trino. I mean, the simple thing was the fact that we could cross our connectors over joins, and we could just write SQL. No one needs to know about Elasticsearch. No one needs to know about InfluxDB. We just write SQL in Trino, and that's it.
You're making Commander Bum Bum blush. Yeah, great.
He's already pink though, right?
So it's a big thing when you're looking at a system like this, because you don't want to make too many decisions up front, and there's other things we want to do down the road. Like we've looked at the ClickHouse connector. We are considering the ClickHouse connector, but this wasn't like, oh, well, now we need to know how to write like whatever you use for querying ClickHouse and whatnot, and oh, no one's worked with that. It's like, great, we spin it up in our EKS cluster or Kubernetes cluster on Amazon, and then we just write the SQL on Trino, as long as the connector's there, or we could write the connector, but everyone knows how to write SQL in the company already because we're using Trino. So it's like, great, you don't even care that's ClickHouse. But from the infrastructure standpoint of the data platform, we might care greatly that it's ClickHouse.
A lot of code that you don't have to write there.
Yeah. As well as we have things like, we're using Hive, right, in this example, and we're going to talk about us moving to Iceberg. The changes for us was just changing where we're pointing to. The SQL we could leave the same, assuming like both connectors supported all functionality of SQL. But for us, yes. So there wasn't a massive change. It wasn't like, oh, we have to change every single line everywhere we're dealing with X to be this new format. Literally, we just, hey, we're no longer pointing to hive.datalake. Blah blah blah. We're now on iceberg.datalake. Blah blah blah, and that's it. So find and replace is essentially the switch over for us.
Nice. I see this kind of end point of like report semi-interactive queries. Are these views or what actually is what is the materialization of this these?
Yeah, so we are kind of got a form of materialized views, but not from like a Trino perspective. So we are generating out JSON files that we store back in S3, and those are front-facing to the UI. So the UI sees a materialized view, but in Trino, there's not an actual materialized view.
The materialized view is a JSON file. That's funny.
Because like we can just serve this up over REST, and like the UI has no idea.
I know.
As well as like from the product standpoint of us, it's because that is a materialized data, like that's the data being materialized, but the UI has multiple different representations. So they might have to take that and then show it as like components or widgets on the UI, or a PDF or a CSV or etc. So just serving it up as like essentially like, here's REST, here's JSON, and they have no idea about anything else. So as well as there was risk management, right? Like it's a big sell in the company when you come in with a lot of bleeding edge tools. And in this case, like even if we had something like an outage in Trino or outage in our pipelines or, S3, the connector goes down and we can't even get to S3 for wherever this is, our store JSON files in S3 are just static.
Mm.
So literally, I can go in and delete Trino today, and none of our customers would even know. Like they wouldn't know that we're actually having an outage because a lot of these reports are just static S3 files.
Yeah.
So
until they don't get new ones.
yeah, like there's a lateness, obviously, but a lot of what we're doing on the report side is generated daily. So it's like right now, like high level executive reports and things like that. So as long as the outage doesn't exceed like a 24-hour period, no one would ever actually know.
That's a nice little buffer too. Yeah.
Yeah.
That's a very like interesting view to generate the like sort of like the cached reports basically as just JSON raw files. It's interesting.
Just risk mitigation is what it came down to for us, and also like we can continue because we couldn't do the live queries we're doing on Elasticsearch with the Hive connector for some of the reasons that we can get into.
Sure.
So one of the first reasons is our system is like essentially DNS logs, and it's from like a security standpoint. Some of our customers use it to scan their systems and know like who's talking to what on their device network, or like what devices are on the network. So they don't want a lot of latency in seeing that stream. They want it as soon as possible. And the old
because there's security implications and stuff like that, right? Often.
Yeah, as well as like just they use it for like monitoring outages from Office A to Office B or misconfigured routes. So they want to know as soon as possible. The problem is the way that we're dealing with ingestion is the customer ships us data in like, it's like, I think it's like 100 megs or a maximum of 3 minutes, whichever is exceeded. So we end up with a lot of these small files. And then when this comes in and we store it to S3, so when I want to run something on Trino, it's like, oh, select all from DNS data on the Hive connector. And even if I give it partitions, right? Like I only want today's data. The problem is that customer might have generated like 4,000 S3 files because it's very small files. So we couldn't do this live query analysis with Hive, at least in the first stage. So we have this compaction problem, right? Like as the slide says, our data arrives in S3 as a lot of tiny files. And we don't want to delay that and make larger S3 files because that would introduce latency. It's extremely slow because like some of our larger customers will end up sending us like 65,000 S3 files in a week. And you don't realize how slow it is to ask Amazon for 65,000 like get objects. Even if you're only like, that's already partitioned, right? Like I'm already eliminating historical data. Like I've already specified a partition just for that week, but in that week it's 65,000 S3 files. And there's data pruning, obviously, that Trino can do, but the problem is and we're using Parquet format. So the problem is that for that data pruning to happen, it needs to first get that S3 file, right? It needs the Parquet metadata. Hey, I'm looking for DNS over UDP. And yeah, that's one of our columns. We store the metadata in Parquet. We know what files, what's stored in that file. And that file might be all UDP, or it might be only TCP, or it might be mixed. But just for Trino on executing his query, it needs to know like, hey, I don't know if I can prune this file without first getting the file to read the metadata. It might not even read the whole file. It might literally just reads the metadata sometimes and says, nope, I don't need it. But that's 65,000 calls.
Yeah, yep.
That's what Ryan was also saying in the last meeting, right? Where he was talking about that problem of just how HDFS, like how Hive is hooked into HDFS historically, where it is used to reading from like a file system, and that's fast. But now the file system is in the cloud, which totally messes that architecture up. So
yeah, and then on top of that, you know, it starts adding up. Like Amazon's very happy because you're paying for all these list objects and get objects, and it was just becoming a hassle. So we end up saying like, okay, it's not such a big deal if we just have compaction. So we're going to write our own compaction job that basically version 0 is these small files and version 1 will be a compacted version of that. And from the Hive connector standpoint, we were just literally storing it as like a partition of version. So you would have /year, month, day, /hour, /version. And that's kind of how we were doing it in S3. And this is kind of like similar like concept to snapshots, not the same implementation, obviously, but it provides a similar kind of thing that Iceberg was providing with snapshots. But this is a huge pain.
Did you all look at Bucket? I know that like it doesn't solve everything, but
yeah.
Like,
so we had looked at Bucket, but even this didn't solve it much, because it's like, what are we going to bucket by?
Yeah.
Right? Like, and then like we always have customers who want to slice and dice a certain way, and we end up like, oh, well, we're going to have to just get everything across all buckets anyways for this customer.
Yeah.
And it's like, well, we're back to square one.
Yeah.
Right?
Yeah.
So we had a compaction job, and would take these like very small 1 meg or, you know, whatever under files and compact them into 1 gig files. So you go from like a week of 65,000 files down to like 500 S3 files. And we saw like performance just for that, like 3 to 6 times increase right there.
Mm-hmm.
So that was good. Now, the next problem we had with the Hive connector is, well, you have the metastore problem, which is it needs to know what partitions are available and when those are available, which means we need a way to update the metastore. And we're using Amazon, so we're using Glue crawler to crawl the data, except it's really expensive. And you have that trade-off. Like, you would just increase the time the crawler checks, but then we have lateness. The problem is the data is there, but because the partition data hasn't been updated in the metastore, Trino doesn't actually know, like, hey, there's a new hour, or there's new stats about this that I could use on the cost optimization stuff. So we even tried to do this on ourselves. Like during Flink, you're seeing all data, right? And you know when you're syncing this data. So we thought, well, maybe we can just make the API call to Amazon to actually just update Glue and not have the crawler do anything. The problem is, like, the S3 sync in Flink doesn't necessarily expose the file to us. So we hit a roadblock there, and we just couldn't get around it. Plus, this is more code. Like the same thing with the compaction job, the same thing with this. It's more code.
More maintenance, yeah.
Yeah, and it doesn't provide any value to our customers. Like, this is all behind the scenes to them. And it's not DNS data. It's nothing related to DHCP, IPAM, or DNS. This isn't our business. We are not an Amazon, right? Like, we're here to provide value on the DNS data. So yeah. Plus the cost was, I already said the cost was getting ridiculous. Like, the crawler itself with all the S3 list objects starts adding up. Like,
I don't know if that can be stated enough, though. You know, it's like when you get that AWS bill, it's like, holy.
Amazon was probably happy though.
Yeah, for sure.
Yeah, like it wasn't like so much that we couldn't run the system. It was just like, as we continue to grow, this cost is going to just become an issue, right? Like, we need to find a way to, like, even if I said it's linear cost, well, we don't want linear. We want like a log projection, right? So it wasn't working. So this is what this all kind of looked like before Iceberg with the Hive connector. We wrote our own custom compaction job. We're using the Glue crawler for the Glue metastore. We still have our ingestion happening with Flink and Pulsar into our multi-tenant data bucket. We're still using Trino on the Hive connector, and we still have our reports. So this got us, the advantage was we had compaction working. That got us that 3 to 6 performance increase. We did decrease the cost of the Glue crawler because there's less files to crawl, as well as on the Trino side when it's making, like, not Trino itself, but behind the scenes, it's making the S3 list objects and get objects. So that decreased our cost on that. And life was great, except until it wasn't, because we had to maintain this. So Iceberg to the rescue. That's kind of what happened. Was I don't remember if it was Ryan who did a talk, or I think maybe it was the Adobe blog post that they did on Medium talking about Iceberg. That
one's fantastic. I need to add that to the show notes.
That I finally re-pulled it up after a year. And internally on the team, we always knew that we would probably be going to Iceberg. Even back a year ago, it was like, this is going to be the winner. Just reading what it did. It's just not where we need it to be. Like, at that time, there was no Flink support, and we were very invested in Flink, and it was just too much of a sell. And we didn't have the capacity to dedicate to build out the Flink stuff. So
what did you do when you found out Flink support was coming to Iceberg then?
So it was like, that's one of many check boxes. It was like, oh, do they support the hidden partitions? Like, how's this work? And have they added everything? Have they forked? Like, has V2 come out? What's in V2 yet? As well as the compaction stuff. The compaction was a big thing. Like, okay, great. Iceberg is going to provide us this way that we maybe don't need the glue metastore anymore. But what about compacting all these small files? But then reading the docs and everything and seeing where they evolved, it's like, oh, they solved that as well. Like, that's all part of like the maintenance actions. And it's like, great. So so we essentially was like, okay, let's leave everything running as is. And let's just basically piggyback on our existing data and write a new Flink job and just duplicate our data, but in the Iceberg format. And let's see if it works. And, through trial and error, we got it to work.
I love that. It worked.
Yeah.
Bullet 4, and it just magically finished everything for you all. You can all go home.
Yeah, I mean, like, as we're talking, like, okay, we didn't need our custom stuff anymore for this. It's provided by Iceberg. We run Iceberg has the maintenance actions and they support Flink. So we just basically kick off a Flink job and it does that. And the way that the data format is of Iceberg, we don't need the glue crawler to go in and update the partitions because it's stored in the manifest files. And then like the glue, we still have glue metastore, but this is a whole other thing. It's just a pointer to the actual manifest stuff and all that, but we're going to get rid of this anyways. So I mean, it was great. Life is great. We delete our compactor job and everything is good. And, we just kept going. It was like, okay, we have Flink and Trino support with Iceberg. We can still use the Parquet stuff. Great. Hidden partitions was something for those unfamiliar with Iceberg. But if you're familiar with Hive and Trino world, when you write or craft your SQL, you're including the partitions directly. For us, it's like customer ID. Actually, that's the catch. For us, customer ID is a reference to the data itself. Customer is a reference to the partition. And what we had happen internally was someone wrote a query one time where it was like select all from blah, 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 where customer ID equals the customer ID. The problem is that's not the partition. So during planning, you can't prune that on the S3 path. You actually pull in all customer data and you're literally looking down the row and you're like, oh, wait, I don't need this. I don't need this. I don't need that. Except, you just ran a query on like hundreds of TB of data versus if you did it by partition, we're down to like, I don't know, for this customer, maybe like less than 1 terabyte of data.
Oh, no.
Yeah. It's like, why are reports taking like 8 hours to generate? Like, and it was just pulling up Explain. I'm like, I don't see any of the dynamic filtering. Okay, that's weird. And it's like, oh, because you're using the actual data in the SQL, not the partition. Yeah. So it's going to get everything and then only prune once it can actually go through the data itself and not at the S3 location where it can just drop everything. Yeah.
This is exactly like that. That's like the whole reason for hidden partitioning. Like that's the perfect poster child like use case.
but from the person writing the query, it totally makes sense.
Makes sense, yeah.
Why would you want to care about what partition this is in? It should just work, right?
Yeah.
Yeah.
So and so that happened like I think once or twice. So that was like, okay, this is going to happen again. And you can just build tooling around this to make sure like, oh, we could put a listener on Trino side to make sure that there's always a partition, like on customer at least and things like this. But it was just nice that Iceberg solved this. There was no custom compaction. We could literally just get rid of our compaction. And I don't think people realize just how complicated compaction is. I know me and Manfred were just talking about this yesterday. Like, it's like the best interview question. You ask someone like, you have small files and you want to compact them into large files. Like, how would you do this? Because you get into like, how do you lock? How do you guarantee that it happened? How do you get rid of the old data? When do you get rid of the old data? Like, how do you actually make sure like it atomically happens if you're swapping? And then just what's the optimal size? Like, like how do you get all that information? How do you it's such a huge thing. Like I was telling Manfred that the RFC for Iceberg's compaction was 9 pages in a Google Doc. And even then they're like somewhere in there, there's like, and there's a lot of work to be done in X still. And you're like, so less code, the better. Like,
the good thing is someone else has thought about it, so you don't need to scratch your head, right?
And as they improve it, we just get all the benefits. It's like the same thing of why I was saying I love the release notes for Trino. Like every 2 weeks comes along, and usually I'm like, oh, that actually might increase our performance. Oh, like that makes my life easier. Oh, I don't need to do this.
That answer to that question too of like how long do you keep things around? Like you keep things around for a while until you are able to like 100% have like all the checks run and make sure that that data that you thought like that you have moved into this like new shiny compacted state is like still existing. So like Iceberg does this through snapshots, right? Like you don't see the existing one, but you have older versions where things were all scattered all around. And then at some point you say, okay, like that stuff can eventually, like that stuff can now go away because now in this new snapshot, I have like done ideally some check that will, validate, hey, the same row count that I get for running this query is the same row count I get for running the old snapshot query, and remove all those old ones,
Yeah, it's a part of, I believe, the manifest metadata itself. When it makes the new snapshot, you can actually see the files that were created in the rows of those files. So then I can actually just use the metadata to confirm like, hey, before this snapshot, there was 100 million rows. And now after this, that it still references 100 million rows. Like I know that everything is good to go.
And if you're super paranoid, you can do any amount of checksums you want. Like it's super simple.
Well, the beauty with Trino is, and our migration from Hive to Iceberg is, I just select between both connectors and say like, hey, look, is there anything missing between these two joins? And if there is, where? And the hidden columns on Hive side, I can even say what files, right? Like, so it makes it very, very convenient. But yeah, overall, it offered us a bunch of stuff. So where are we today? This system's ingesting about 20 gigs an hour with, if you want to call it complex schema. So it's multi-nested and all this. And we are compacting using Iceberg, using their Flink actions for this. And we have Trino actually working through this. And the things that we have left is garbage collection in the sense of like, Iceberg provides us the actions in Flink to do things like find orphan files. If there was like 2 writers running at the same time and something crashed, like you could end up with an orphan file. It's not that you've lost data, it just hasn't switched over, and you would have orphan files. But we don't have any tooling around this. And one thing with Iceberg is like you have all the things you need, but not necessarily the things that are going to be like, oh, by the way, I'm just going to automatically go run this myself, or I determine you should run this. It's more like you trigger the action. So we're just trying to figure out tooling around this of when we want to do that. When can we notice orphan files on our own, when we should trigger the action. And then the reporting is like our actual customer facing stuff. Right now we're still using Hive, but we need to switch this over, like that JSON file generation I talked about, that's still using Hive. And we just need to switch over to point to Iceberg. So this is just me iterating the same thing I kind of just said. When do we trigger maintenance? How do we monitor the orphan files? When do we clean up prior snapshots? All this kind of stuff. But this is just like internal business stuff. Like, when do you feel comfortable? When have you done all the checks and balance? And, I was saying we were looking at using Trino for this itself. Is in Iceberg, I can get the metadata about Iceberg files. So I can actually go look like, hey, are the Iceberg files compacted enough? And what files aren't compacted? And, select me all the files less than 1 gig. Get me a list, and then I can send that list over to Iceberg in an API call and just say, okay, these are the files I want you to compact. What
are the kind of remaining roadblocks to kind of fully migrating over to Iceberg? Like, is there a pretty close, or do you still think it's like some quarters or months away?
So I guess this is perfect to go into the pain points.
You're welcome.
It's literally early days for Iceberg and Trino. So like we still have issues where the compaction job, like on Iceberg side, doesn't give us a lot of insights to like what's going on. Like it takes us sometimes like 6 hours to run the compaction job. Sometimes it just fails on the Flink side. So these are blockers. And like there is improvements, like we are seeing contributions come in, like more visibility and better compaction strategies. And Ryan's talk with Manfred was good to give us insight also to like how Netflix is doing it. Just like, hey, are you doing just small files? Are you just saying compact everything since the beginning of time? It's all the things like the doc doesn't give you explicitly. It's like, call this and you can do compaction. And you're like, great, but should I do everything at once? Should I break it down? How do I break it down? Also, we're still unsure of if I call compaction twice on all my data, like first time from beginning of time to the end, and then I call again, is there any logic there that says like, I've already compacted this? Or is it literally just going blindly like go in and recompact everything?
So from like that came up in the meetup, by the way, with Ryan last time. And for those of you that have missed that, it's available on YouTube. So me and Ryan Blue.
I'll add it in the show notes, by the way.
That will be in the show notes. So anyone that's interested in that kind of stuff, he was saying that it's basically a no-op, but there's like edge cases, so you'll have to test it out. But like you can run compaction multiple times, and it'll just be no-opping over stuff that it has some internal tracking on what's already there. So. But if you don't want to try that on huge amounts of data where it costs you a lot of money.
Yep.
Sandbox it for sure.
I think a lot of it is just like the tooling for us to go all the way. And also right now we're stuck with DynaDB because Glue doesn't support the atomic actions that we need. But that kind of comes to this, which is like, so there's no like first class support for the Glue catalog with Iceberg if you're using Trino. But there is this lovely pull request. It's in the works. I know there's some discussion about this. Also, this isn't a blocker to us moving. It was just a blocker for us to make progress initially. So all of our data was being written by Flink. And when Flink writes this Iceberg format, what happens is it doesn't write anything in this storage descriptor key. And what happens is somewhere in Trino, we had found the line, it expects this value to not be null. And if it is null, it is not happy. I don't remember if we get exception or it just says like, oh, like it can't even list out the schema or what it was, something. So our hack solution in this case, and it's related to this pull request, which was just like, okay, we're just going to write a dummy value and Trino passes along and says, yep, okay, cool, great. So yeah, it's early days.
We should check with Ryan and see if the storage descriptor is allowed to have a null value according to the spec, and then either fix the Flink thing or whatever, right?
So it's just early days, so we're taking our time and just shifting. And right now the system's already working. It's just not as good as it could be. We had issues with like compaction job. Like I said, it would just fail. We had to do a bunch of like tinkering around with it and trying to figure out how we would get this to work. And there's just a lot of things that are even undocumented. Like, I think I was telling Manfred yesterday when you jumped off was your blog post was like just the stuff we had learned last week. And your blog post was about like, oh, look, Trino can actually expose you all this internal stuff about Iceberg. It's like,
so Manfred is actually I think you have a PR in already, right, Manfred? To add.
We're working on getting the SQL support documented better.
Yeah. So yeah, I found it through diving into Slack and asking people directly, and at this point, like there is. I'd say if you are motivated enough and you could technically get Iceberg up and running for a production level support, right? But you have to have a lot of like people that you're talking to. You have to do a lot of documentation. You're going to be spending more time on rather than actually implementing anything, probably just figuring out what stuff's going on. And that's, I think, the most main. But that being said, like it's taken a lot to get, there's been a lot of work being done that's already been done to kind of get it to where it is today, where it's, you can, use it at a production level. There's just a whole nother effort that we're all kind of all working in right now, trying to A, get it documented, and then B, just kind of finding these like, compatibility issues where, maybe the spec didn't quite specify something very clear. So, one project kind of interpreted it this way and just maybe didn't interpret it at all and just kind of left it to, leave something that gets,
I think that happened before with like uppercase case sensitivity somewhere before, and we ran into the same issue.
Yeah. So and it wasn't like that wasn't a huge issue. That was like it messed up a show command, and so like in terms of prod level type issues, like it was a bug, but it wasn't like something that ideally like probably would have broken anything down, like especially had you done like a test before. But it's definitely like, these things are reproducible errors at this point. It's just, there's a lot of small little things that, across the board, there needs to be a consensus on how this actually is done versus kind of leaving it up in the air, I guess.
Yeah. So this was what we were just talking about. We weren't sure if it recompacted. And even when I talked to Ryan, it's like, oh, it's because the case he's talking about it not recompacting is related to deletes, but that's only if you're using V2. And because like Deflex's next gen bleeding edge, and he's like, oh, it won't recompact or attempt to recompact already like files marked for deleted. It's like, okay, yeah, but non-deleted files, what's going to happen? Like I'm talking about files that I just want to actually collapse. Is it going to just attempt to recollapse? Like there's just a bunch of things that you really have to dive into the code, or like you were saying, you need to know someone that's already running it to go like, hey, what's happening here? But summary is basically like, I think it's the future. I think even if you're small like us, and we're not nowhere near Netflix size, but the benefits are like just the compaction. Even if you wrote it yourself and you weren't using, like we saw 3 to 6x speed increase.
That's cool.
That's awesome.
And and it's nothing on like necessarily like oh, Trino's able to do this faster. It's more or less like, great, I don't need to ask for 65,000 files anymore, and I just ask for like 400. On Iceberg, with just being able to kick off the action and get compaction out of there, it's like it's gonna be huge. As well as like, even if you already had relatively large files, it's the fact that if you had a lot of customers or a lot of files you're producing, even if they're large, it's the fact that Iceberg only goes and gets the manifest list, and once it has that, it has the metadata about every single file and all the the same thing like for us Parquet, like the same sort of metadata. So right there, it reads essentially, for most people listening to this, it's going to read one manifest list file or n, but it's going to be like much smaller than what you normally have to read on all your data files. And then from there, it immediately knows what files to not even go get. It's like, great. Like, and I saw that they want to add Bloom filter support in the manifest list. So then, like, if you have large things with like large dictionaries, you could use a Bloom filter. So that would just speed up. But yeah, summary is like, I really think it's the future. I think the Hive thing is going to go bye-bye. Like, that's my opinion. But
for sure,
like once you start getting rid of like the Metastore and you start being able to just run just Trino and just your data, and you just happen to have the Iceberg format there as like this Metastore middle layer, it just solves a lot of problems. So
yeah, I think you're totally like, we definitely are saying bye-bye to Hive. Like I would bet money on that, a lot of money on that. And then like, I would just say that, the question for a lot of people right now is, with these new table formats, emerging, who's going to be the one that sticks around? Like, is it going to be Iceberg? Is it going to be Hootie? Is it going to be Delta Lake? And so, there's all these kind of questions about which one. And I think really in my mind, when it comes to, Delta Lake was the kind of first people to take a run at it. They had a whole like enterprise focused in on this, and they got there first. And then Iceberg kind of, came as the open source savior that not only open sourced this, this really cool and efficient way to handle a lot of these pains that we've had with Hive, but now they put a spec around this, a specification around this, and now it's something that can live outside of a specific implementation. And that's where I think the true power that brings this forward into the future, right? It's not just oh, we have this implementation and you have to know this implementation, or it has to, we have to change the implementation to get it right. No, it's everybody's kind of in the game of implementing it, where actually the most important thing is getting the specification correct and getting everybody aligned on how they do things. That's going to be the real strength moving forward. And you can make 500 different icebergs at that point and figure out which one's the one you want, so it's beautiful. So anyways, Corey, is there anything else you wanted to share before we hopped on to the last bits of the show?
No, not unless you guys had anything. That's it.
Okay.
It's been quite a journey, and it's still kind of the early days of it. But I mean, you can't argue with less code, still get performance, decrease costs. At the end of the day, that's what every business wants to hear.
Yep.
Also, that's what you want to do as a developer.
Yeah, exactly.
There's nothing more satisfying than a refactoring where you delete more code than you write.
Yep. Okay, well, with that, we didn't have any lingering questions, so let's move on to the PR of the week. All right, so we have PR of the week, and this is a PR. Let me pull it up. I should have preloaded this. There we go. Adding the format number function. And so this is actually a totally brand new function that was made by Yuya, one of our maintainers. Yeah, it's basically is an issue he had brought up before. A lot of times when you're pulling data out, you have these super long, large numbers. Sometimes it can really make a bloaty looking table that gets returned. So just to have a nice quick little format number function that kind of takes care of the bloat and makes it a nice compact little value, especially when it comes to looking really quickly over a set of values, to have that kind of easy to read, ease of reading versus just a whole long list of numbers is just much nicer format to view. So this format function was added. It fixes this issue 1878, which I think also you put out there. I'm guessing he needed it. So and it's crazy is he pulled it out in 2019, kind of almost not quite 2 years ago, a year and a half ago, we'll say, and just now got to it. But I mean, that's how it is, right? You're hoping somebody will jump on it, and they're well, I guess I need this at some point, so might as well take care of it now. So this was added into 357. Yep. And I think one thing he pointed out was that just the only note I'll make about this PR is there's a format utils, and this is actually a broken link now with the rebrand. Let me go to the one that he brought up. But there's a format utils class in the CLI that kind of does something like this a little bit, but I guess it was missing a couple specific cases that Yuya was, I think, particularly interested in.
And it's in the CLI, which then doesn't help you if you are not using the CLI.
That's also true, yeah. So he wrote his own, and I have that link there if you want to dive into the code there, and just basically similar type of code, but just also accounts for a couple other of these, I think, negative situations. So without further ado, let's go ahead and run the quick demo. Does it make sense to have the same sound, or should we have like different sounds for each thing?
I guess you have to do a ding and a drum roll and whatever, but
yeah.
next time.
I thought about sirens possibly for a demo, is like because usually they just don't go. But anyways, let's take a look at some of these outputs here. So if we have 1, 2, 3, 4.5. May have already run that. All right, 1.23K. And by the way, so that's casting. He tried casting doubles. I'm looking from some of the ones they pulled from his test. You do some casting. You can actually do it on actual like just direct values, numeric values. We'll have the same. We can look at these super long negative values, and you'll get the same thing for the positive values here. And then 999 is the cutoff for like just leaving it alone. And then if you go to 1,000, you get negative 1K. And same thing if you do positive. So it's a simple in concept, but yeah, and I think for those that are kind of wanting to see a code change that doesn't really touch like a huge amount of code and isn't really super complex, I think this is a good PR to start out with. You can just kind of dive in. Let's go look at there's like
next someone's going to ask for the opposite of format number. They want to go from format number back to a real number.
There we go, inverse. So yeah, give me this blown up. So this is touching 6 files. It's not, there's one class that he created and then a big testing function. So pretty easy to see how, if you wanted to add a function, it's not a huge amount of code change. So if you are wondering how that works, definitely give PR 1905 a look. All right. So we've done PR demo.
And by the way, this is just for formatting numbers. Of course, Trino has lots of other functions to formatting strings and stuff for that. If you want to do more massaging, you can.
Oh yeah, definitely. I mean, here, let's do it quick while we're thinking about it. Just go, if you wanted to look at all the different functions that we have, you go to the Trino. I just clicked it really fast, but Trino docs, and then you'll basically come to this page here. And we have it split up into, logical docs. This one would probably fall under format. Or is there a format one? There's probably got to be a string.
There's string.
String, okay.
By the way, we are probably going to reorder this to be alphabetical or something. Because
yeah, I'm just going to do a number. It's not showing up. Why am I? Oh, well. I'm guessing.
It format number?
Is it format number? Ah.
Yeah, format,
but then we don't have format number. Or let me see. Yeah, we don't have format number on here. I'm guessing it's under one of these other ones. Maybe it could be.
Maybe they didn't add the docs yet, but.
Oh yeah.
So that's by the way one thing that I'm doing regularly now. I'm gonna look at all the release notes and then go and.
It's under conversion. it was not under. Yeah. So there it is. So if you want to, but this is the same location that you would find all these cool little functions, and these things fill in a lot of gaps that maybe it's hard to do. And in SQL, you have like a nice, convenient function to pull these things out for you. So, all right. Sorry, I didn't mean to cut you off, Manfred. Is there anything else you wanted to say about that before we head on to the question?
No, I think that's cool.
All right. And for the last time, to the question of the week. So, question that was posted on Elasticsearch a couple days ago. New to Trino and just wanted to know that this is again back to the Elasticsearch connector. How do I search on nested objects? So this kind of gets into some that may not know the difference between like what a nested object would be versus like a regular object in Elasticsearch. Elasticsearch has a way on how they do indexing, and when you push in an object, you're basically just pushing in like the full document. You have this option to use a nested object, and it basically just takes the object and stores it in a separate index. So that, and essentially what you would have to do is perform a join to pull this data out. And this ends up becoming a much faster search on the direct like nested object itself. And you can do, there's some functionality, I can't even remember exactly what it is, but there's like some equality functionality that gets opened up that doesn't exist with the standard object. So depending on what kind of searches you're trying to do in Elasticsearch. So Trino doesn't care about that though. Like these both to Trino is like, they're both just regular objects. So like we just map this back to a row. And so what you would need to do is like, you know, to answer this question, if you knew that information, you would say, okay, well, what's the row syntax that I would need to know? So I answered this question. So basically the first time I'm showing this like linked products example that they have is the nested object, and then it has this ID. So what you would do, and let me see if I can make that a little bigger. You would have there we go, linked products.id. So that's the row operator to you know, basically access a named column within that row. So linked products.id, and that solves it for that. But one thing I also kind of dug into with this question was like, you can see that the product name in the question, in the original posters thing, they said linked products. So I'm assuming that this is actually an array. And this brings up another interesting point with the Elasticsearch connector in terms of how Trino views the world and how they view the world, is that if you are to treat this like an array, Elasticsearch has really like very little concepts about like array, basically scalar versus a multi-value array. In terms of the value. So if in the same way that I can push in a single linked product, you know, this is actually like, you know, curly brackets that surround this thing, and I'm actually pushing in this object to it. I can also push in an array of objects, and that to Elasticsearch, like everything at the Lucene index level is all represented as arrays. So this one single object gets represented as an array object of 1, and the same thing for this it ends up getting represented as, you know, an array of 2. So Elasticsearch, just based on how Lucene indexes and basically inverse indexes work in general, you know, that's just how Elasticsearch views that world. But to Trino, we need to know, is this an array or is it not? And so ultimately, like, there needs to be a mapping. And so if you pushed in this object, the second row, and you tried to run the same exact query, you would get a query failed because it's saying linked products is expected to be a row type, and in fact, it's actually some array type. So to fix that, you would want to, we have this way to indicate to Trino, this has this old namespace wrapper of Presto. We will be getting that updated at some point soon. But you basically have to indicate to Trino, hey, this object at this same like root level called linked products, that's actually an array. So you actually push that value in and to a field called the meta field. And that now is going to get searched by Trino and says, okay, show me which fields are going to be treated as arrays, and then I will, you know, deserialize that as an array of objects versus just a single value. And so now that we have that, we're treating this like an array, we have to update our select query. You can use the element at in case that's another function that allows you to do a particular location in the array. And you can basically say the element at this location in the array, and then do the same nomenclature as before, .id, and then we just recast it as ID1 versus ID2. And so if you run that query now, the first column, again, we had no value for ID2 because it was just a single value. But then the second part of the array, that came back with the 456 that was inserted in this second ID here. So a little extra answer to that question than was originally asked. But I think it was, I think that would have been the next problem that user would have run into. So that's basically what I wanted to have to basically have covered there.
I hope you got that answer accepted on Stack Overflow. That's a lot of work you put in there. That's a good answer.
Yeah, I
deserve some points by whoever.
It's a new it's a new person, so I don't know, like sometimes new people don't typically know, like, or maybe he asked and then forgot about it. But if anything, I like it just to have it there so that if anybody needs to reference it and find it, at least it'll be for them. I'll get the plus 10s here and there, and that's fine enough for me.
Exactly. So, now here's the call out. All our viewers, go to your Stack Overflow account from the show notes and upvote that answer.
All right, thank you. So okay, so I think with that, that's pretty much the show. Manfred, did you have anything else you wanted to cover before we hop off?
Just off topic, greetings to all our friends in China, and good news. Unbelievably and unbeknownst to me, a simplified Chinese translation of Presto Definitive Guide is available, and it looks awesome. Like, I just love the different character set. I can't wait to get a paper copy as like sort of the author with Matt and Martin, and it will be updated to be a Trino the Definitive Guide version as well. So yeah, we're taking over China as well with Trino. Hey.
Yay! We already have a Japanese one, or what are the other translations that currently exist?
I don't know if that's any other translation, but if you someone in the community wants to work on the translation for Japanese or whatever, please do reach out to me. I can hook you up with the people at O'Reilly. It would be awesome.
Great. All right.
It's kind of insane to think that a book that I was participating in is available in a different language now. I guess I should get my act together and make the German translation.
I was just gonna say we have plenty of people in you say so, and you would be able to translate it to German?
Well, it's my mother tongue. Do I still feel like I can write a book in German? I'm not so sure.
Okay, well, challenge accepted, right? I guess we'll look forward to the German translation. And
yeah, if someone over in Europe, Germany wants to help with the translation, I'm sure we can sort of hook that up with O'Reilly somehow and figure something out. I'm not sure.
Yeah, totally.
But yes, we do want to take over the European market as well. So we're working on that.
For sure. Awesome. Well, thanks everyone for attending the show today. Music for the show is from Mega Man 6 gameplay album by, I just looked over the pronunciation to get this right. I'm going to have this on a recording the next time so I don't keep butchering this poor Polish guy's name. Krzysztof Slawikowski. And
you need to just get one of our committers to say the name for you, record it, and use that.
Yeah, exactly. I'll have, if Jan's still on, Jan, you're going to record it for me.
Exactly.
And then you'll be the outro every time. So thanks everyone. See you in the next show.
Thanks for joining us, Corey.